Hi everyone, I am Dr. Surjit Singh. Today we will talk about the Leetcode problem of deep copy of a linked list which has two pointers. Welcome to my video. Let us begin. We are given a linked list which has two pointers. In addition to the next pointer, we have an extra pointer named the random pointer. We are to make a deep copy of the list. It means that all the nodes will be copied into new memory locations. In the first method, we will consider a recursive solution to this problem. Consider the linked list as a graph. This means the two pointers of every node are the edges of a graph node. As we traverse in depth first manner, we will clone all the new nodes. Because of random pointers, some nodes are visited again. This indicates the presence of cycles. So we will keep track of all the traversed nodes in a dictionary. We convert the given list to a linked list to obtain its head. We can see that in addition to the next pointer, each node also has a random pointer for which values are given in the list. Copy random list is a recursive function. It returns the memory address of the clone of a node in the original list. Head is the pointer to the beginning of the given linked list, so this function will return the head node of cloned linked list. We define cloning dictionary to keep a mapping of memory relations between old and new memory nodes. Memory of the old node is the key and memory of the new node is the value in the dictionary relations. Suppose A, B, C and D are the memory addresses of the four nodes of the given linked list. Our aim is to create four more nodes named A prime, B prime, C prime and D prime such that they have similar links as A, B, C and D. Dictionary is empty to begin with and in the first iteration head is A. If head is none, its clone is also none. However, in the first iteration head is not none, so this if statement is skipped. If a node is present in the dictionary, it means that it was already cloned and the address of its clone can be obtained from the dictionary without going further. However, in the first iteration, head is not in dictionary, so this if statement is also skipped. Therefore, we create a new node called clone with val same as val of head. Let us suppose that the memory address of this node is A prime. We save this pair in the dictionary for later use. This entry means clone of A is A prime. The function should now return the clone. But before that, we need to set next and random pointers of the clone corresponding to the original list. A next is B and A random is C, which means that A prime next will be B prime and A prime random will be C prime. We will create these links one after the other. First we create clone of head next and save it in clone next. This means we will recursively call this same function once again to get the clone of head next. Head next is B, so B becomes head in the next recursive call. Call stack remembers the position from where a recursive call originated and later continues the execution from the same position. We indicate this by white arrow in the program. In the new recursive call with B as head, execution starts from the beginning. B is not none, so the first if is ignored and B is not in dictionary, so the second if is also ignored. So we create a new node with val equal to 8 and save its memory in clone. Let us call this memory B prime. We save this pair BB prime in dictionary, which means for node B, its clone is B prime. During this iteration also, we reach the statement marked with white arrow where we make another call to the function with B next as the argument. In the call, the head is C. Recursive position is always saved in the call stack. We skip the two if statements. Once again, C is not none and is not in the dictionary, so we create another node in the available memory which we name as C prime. We save it in local variable clone and save it in the dictionary against C. Next entry in the call stack is for head equal to D and we get this tabular record. Now that head next, that is D next, is none, the next recursive call is for head equal to none. First if statement of the function returns none, which is received by the previous call at the statement with white arrow. So none is stored in clone next, which means D prime next becomes none. But D prime next is already none, so it has no effect. Next statement after white arrow is the statement at orange arrow to assign clone random in another call to the function with head random as the new head. D random in the original list is A, so A becomes the head in the new recursive call made from orange position. As A is not none, first if statement is skipped. However, A is present in the dictionary. It means that A was cloned already. So we look for the value corresponding to A in the dictionary, which is A prime. So clone random becomes A prime, which means that D prime random gets the value A prime. In other words, D prime random points to A prime, for which the link is shown like this. Now that both the links of D prime are set, we return D prime, which is received by the previous call at white position, and C prime next gets the value D prime, which means that C prime next points to D prime. After setting the next link of C prime, we move to the statement with orange arrow to set its random link, and we make call to the function again with C random as the head for the next call. C random is B in the original list, which is present in the dictionary, so it promptly returns B prime, and therefore C prime random points to B prime. Last statement of the function returns C prime, which means that B prime next now points to C prime. Next statement, which is at the orange mark, makes another call with head equal to B random, but B random is none, so return value is also none and B prime random remains none. Last statement of the function returns B prime, so A prime next becomes B prime. Next statement is at the orange position, in which we call function with head equal to A random, which is C. C is present in dictionary and it returns C prime, so A prime random becomes C prime, which is shown like this. Last statement is return clone, which means A prime, which is the final head of the cloned list. Time complexity is of the order of n because every node is cloned only once. Each node makes two entries in the call stack. Space complexity is of the order of 2n, which is same thing as n. Now we consider an iterative solution to the same problem. This time we traverse it as a linked list and not as a graph. Consider the same linked list. We again define clone dictionary. GetClone is the function that gives us the clone of a node. If the node is none, its clone is also none. Otherwise, we look for the node in the dictionary. If it is not cloned, we create it and save it in dictionary. Both its pointers are none at the moment. Now, the clone is present in the dictionary, we return its address. We are now ready to start with the main function to copy the linked list for which head is given. If head of the given linked list is none, we return none as the output also. Otherwise, we copy head in node and start a loop to process all the nodes. We call getClone for the node. Node is not in the dictionary, so getClone creates it and returns its address. This address is saved in clone. We now proceed to set its pointers. Node.random is the node with val equal to 4 for which we call getClone. As it is not in the dictionary, getClone creates it and saves it in the dictionary before returning its address, which is saved in clone.random. We repeat the same process for the next pointer, create the clone of node.next and save its address in clone.next. In the last statement of the loop, node moves to its next position. In the next iteration, we get the clone of the new node. It is present in the dictionary, so new node is not created. Its value is returned from the dictionary and it becomes the new value of clone. As node.random is none, clone.random also remains none. Node.next is the node with val equal to 4 for which clone is already present. Its address is obtained from the dictionary by getClone function and is saved in clone.next. Lastly, node.next becomes new node. In the next iteration, clone shifts to its next node. Next statement sets its random pointer. For the next pointer, clone of node.next is required. It is not yet present in the dictionary, so it is created in the getClone function and its value is saved in clone.next. In the last iteration, node and clone move to the next nodes. Random node of clone is set while its next pointer remains none. Finally, we obtain the address of the clone of the head from the dictionary and return it to the main program. Every node is processed only once, so time complexity is of the order of n. Each node is saved in the dictionary, so space complexity is of the order of n. Thank you for watching the video. Next week, I'll upload another solution of the same problem in which we will have constant space complexity. Please stay tuned.